left, center, right, center, left, center, right, center. Hey everyone and welcome back to the Instructor. So today I'm going to show you that how can you control a servo motor just using your hand movement. Yes, with the AI head tracking plus Arduino. So when you look left, the servo motor moves the left, and when you look right, servo motor moves right. So this is the super fun human computer interaction projects. So let's get started. First, let's have a look about the data flow summary. So what you can do, we're going to capturing the real-time video using our webcam for the user faces. And after that, you're going to using here a Pythons and the MediaPipe library to detecting here the facial landmark and calculate the head positions. I mean the head directions. If the head is moved in the left or the center or the right positions. So Python is sending a serial command, let's say left, right, and center to the Arduino. It's nothing but a serial communications between the Arduino and the Pythons. And after that, Arduino receive the commands and control the servo motor. And after that, the servo is rotate the left, right, or the center based on the head moments. So that you see in the before. Now, first see how can we basically installing the Arduino as well as how can we do the code for the Arduino. And after that, we jump the code for the Pythons. So our main focus is to creating a serial communications between the Arduino Uno and the Pythons. And for that, you need to uploading the some code in our Arduino Uno. And for that, you need to use here an ID that's called the Arduino ID. So this is the official website for the Arduino where you can download the Arduino software. So you can see here Arduino ID 2.3.6. So you can selecting here your versions. So if you are using Mac, you can use the Mac OS, and if you are using Linux, you can selecting here the operating systems. So let's click on download, and I already downloaded it and I also already installed it. You can also installing here a legacy versions that's called legacy ID 1.8.19. You can also downloading these ones. So if you have the Windows version which is less than 10, I mean which one is greater than 7, you can also download these ID versions. Okay, so now what I can do, I'm simply go inside my Arduino IDE. So all right, so installing the Arduino IDE in my system as well as I load here the INU file, I mean the code file. So don't worry about this code, you will get this code in the video description as a GitHub links. So here you can easily download it and you can load it in the Arduino IDE. So how can you load it? Basically, you can just click on here and click here to open, and you can easily selecting here the INU files that you downloaded from the GitHub. So also you can see in my hand, I have my Arduino. So what I can do, I basically uploading this code to this Arduino Uno. Okay. So first let's discuss about this code. So what you can do, basically we first initialize here a header file called servo.h. So it's basically for handling the servo motor that you can see. It's basically a servo motor which can rotate. Okay. And then after that, we creating here an instance of the servo. So you can see servo is equal to my servo. And after that, you're already creating here a variable for the positions so that it can tracking the last positions to avoid some kind of unnecessary movements. So when it is centered, it means that it is centered. When we move to the left portions, it means that it stay in the left portions. So that's why we just give it here a static position so that when we run it for the first time, so that it can automatically rotating that in the centers. And after that, we have one bias set of functions where we basically writing here our set of codes. So we basically creating here a serial communications between the Pythons and the Arduino. So that's why we created here as serial.begin of 9600. It is nothing but called a baud rate. So you need to give it to here. And you need to also remember this thing because you need to use it in our Python codes. Then you also attach the my servo.attach 11. So attach before writing. Also, one more thing, when you are basically attaching your servo motor, so make sure that you attach this in the PWM port in your Arduino. Okay, this is the main issue that. So the PWM port is supported in number 9, the number 10, and number 11. So I add it to the number 11s, and then we write it down. So my servo.write of 90 degree. I mean, in the start, when we basically start our program, so that our face is look like in the center modes. That's our initial positions. And after that, we're creating here the 4 functions for the left, for the right, and for the centers. So you can see for the left mean when the position is center is 90 degree, and this is the left portions, again center, the right position like that. So you can see that we basically creating here a for loop, and we do it for the smoother motions, so that you can see here smoother motion, you give it here I equal to I minus 5. So the position should be increment from 90-degree angles to the 0-degree angle, like that in the left portions. So you can see my servo dot right, we give it to here our direction. It means that the servo direction is handling like this way, slowly. And you also give it here a delay so that it look cool, that you can see in the demo. And then you give it here position as the left, because you see that we're creating here a variable called position as a center. This is nothing but our default value. Now we're changing the variable value for the positions. Same thing for the right, you can see on here. So in the right positions, our head is right now centered. So from the 90-degree angle, it will go to the 180. It means this is the right sides. So you can see on here, slowly we remove, we increment it. You can see from 90-degree to slowly to the right, like that. So you can see my servo to the right, and delay give it to 30, and position is basically right. Now for the center, it means that while it's not the left, while it's not the right, it means this is the center positions. So if the position is equal to left, it means that I need to give, while the position is basically left, I need to move the servo to the 90-degree angles. It means 0 to 90-degree. These are 0 positions, this is the 90, this is the 180, like that. So again, okay, this is the 0, this is the 90, and this is the 180. Okay, cool. So you can see that from the 0, 90-degree, it will slowly move the servo motor. And when the position is basically right, when I was in the right positions, I need to, when the position is right in the center, so I need to slowly move my head. Okay, and we give it a position as a centers. Now our loop, that's our loop, and if the serial is available, okay, then we read the serial command from it, and from the serial command we give it here three things: one is the left, right, and the center. It's basically coming from the Python code. Okay, so left, the right, and the center. Okay, so now what I can do, I am going to uploading the code to my Arduino Uno. Okay, so that you can see. Don't tell about this circuit diagram. I also show you after the recording of this one, after this recording this code. Okay, that how can you basically connecting the servo motors to the Arduino. Super simple, nothing fancy. So what I can do, this is nothing but my wire. So I just going to connect it. That you can see in here. I connect it here. Now I'm going to connect it to my laptop. Okay, so let's me connect it out here, so that, okay, so that you can upload it, so you can hear the sound of. So cool. Okay, so you add it, and you can see here, in here you can see that COM8, this is a serial port. So make sure that you remember these things. So first what I can do is simply going to verify the code. We verify the code so that we can see that we have any kind of error or not. So when we verify the code, I mean when we compiling this code, and after that we are going to upload the code to our Arduino IDE. I mean, sorry, Arduino, right? So it's compiling, and you can see compiling is case that you can see here, done compiling. Now you can easily upload the code on here. Okay, now you can see uploading the code to the Arduino. Okay, and later on I will show you that that how can you basically connecting the servo motors to the Arduino IDE. I mean Arduino Uno, and after that I jump to the Python codes. Okay, so now you can see that our code is writing 100%. It means that our code is uploaded in the Arduino Uno. Now I'm going to show that how can you basically connecting the servo motors to the Arduino Uno. Okay, so all right, so you can see here we have the Arduino Uno that you can see on here, and you can see here the PWM port that you already talked about. And then you can see here we have one servo motors. So in the servo motor we have basically have the three wires. So the red one is basically the positive connections, I mean the 5-volt connections, and this brown one is basically the ground connections, and this orange one is basically data line cables. I mean, we basically add it to our the PWM ports in our Arduino Uno. So I'm going to taking here an external wires to add it. So you can see that I basically add it to the servo motor first. So here you go, and you can see that we basically add it. Okay, add it, and this one is basically the ground connections, I mean these blue ones, and then the gray color, I think you can see it in the middles. The gray color is basically the positive connections. So what I can do, this is nothing but my data lines cables. So I just add it to my Arduino Uno. So I can add it to the PWM port first. So let's say this is 9, 38, 9, 10, and the 11s. I just add it to the 11s, number 11s. And then this one is nothing but my ground connections, and this is nothing but my positive connections. So I need to the ground, so you can see here in the ground, so this one is a ground basically. And then we have the 5-volt connections. So 5-volt connection is here. So this is how the connections line is look like. Okay, so you can see here PWM port, you can see PWM port, and we add it to the 11 number, and here you can see the ground and the 5-volt we connected. Super simple. Then what you have, we have the phase that you can see on here. This is a phase. I just draw this out, and in these sections, you can see that I just glue, give here the glue, and after that you finally basically add it here like that. Okay, so add it here like that. Okay, then it will mop. Okay, so this is nothing but a simple things, and you can see this is the phase, and this is the sub motors, and this is the Arduino. Okay, and then you have a cables. Here you basically upload the codes. So you can see here the upload the code. Here you go, and make sure that how you basically running this code, and you need to connect it to your laptops. Okay, now let's see that how can we basically write the Python codes. So all right, so you see that how can you basically connect the servo motor to the Arduino, as well as we see that how can you basically upload the code. Now it's time to write our Python code. So you can see that I'm creating here a file called main.py file, and here I write down all the codes. So what I can do first, we are going to import it here, some of the important library. So first you import it CB2 so that you can access our webcams. Then MediaPipe is basically for the face landmark and the face trackings. And then you also import here the serial so that you can creating here a serial communications between the Pythons and the Arduino. Okay. So we also import here the time so that you can give it here some kind of delay. So Arduino is equal to serial.serial com8 and baud rate of 9600. So if I see the code that you can see the code, you can see that basically you can see the serial beginning is 9600. That's our baud rate. As well as if I see the Arduino, you can see COM8. Okay, this is the same thing we give it to here in our codes. Okay, now you can say time.sleep of 2. You just give it here time.sleep so that it not instantly accessing it, so that it can sleep for 2 seconds, and then after that it will connecting to the Arduino. Okay, and then you're creating here a solution for the MP face mesh. So creating here a solution, let's say mp.solution.face mesh, and you're also creating here a video capture object C. We give it to here one. Why? Because we're going to be using here external webcams. So if you don't have any external webcam, you can also using here the Droid cams. So you can just connect to the same network, Wi-Fi or mobile hotspot, and then you can easily access your Droid cams. Okay. And after that, you can see here we actually using here a variable called previous directions and make it none. So why this one? So that our position should be the constants. So if I have the center, so that our servo motor just taking the position as a constant, and it was just move the direction for the one times. Again, move the directions for the one times. That's why. And then with mp.face mesh dot the face mesh, we give it a maximum number of faces is equal to 1, and refine landmark equal to true. You can also draw the landmark on here. Okay, but I don't think that is not needed. So as face mesh and while cap dot is open, it's mean that when the camera is basically open, we checking for the rat and success. I mean, we checking for that if there any kind of issue or not in our camera. So it may be, I mean, it may be happen camera is unable to accessible, so it will give you the false. But when it will give you the when it will give you the true, it's mean that you can continue. Okay, now what I can do, first you're going to converting the BGR to the RGB. Why? Because you know that OpenCV read the images in the BGR format. I mean blue, green, and the red. So to convert them into RGB, because the MediaPipe model is changed on the RGB images, and then you're making these image flags writable as a false, and then you're passing here the images inside the face mesh, and face mesh is basically give it here some kind of results. Same thing, we make it now right now true. Okay, so after processing we make it true, and then we convert back to the RGB to the BGR so that you can show it in the OpenCV, right? Now if the result.face.multi-face landmark, when we detect in the face landmark, then after that we simply going to iterate to all the value from here and checking the shape of the images, the shape of the whole entire frame. From here, we can basically calculate here our nose, our left check, and the right checks from our landmark positions. So you can see that we're calculating here the nose. So face landmark, the landmark are the index number 1, and face landmark, the landmark number 2, 3, 4 index numbers. So from the 2, 3, 4 index number, we basically checking the left check, and for the 4, 5, 4, we checking for the right checks. And after that, we convert the positions. We convert the positions to the Emacs pixels to the coordinates that you can see nose x, the left x, and the right x. So what you can do basically, we're taking here the x and we multiply with the weight so that we can get in here our nose positions. Same thing for the left check and the right check, because we have the index numbers, so we're checking here the position of the coordinate in our frame. And then we're checking for the face center, if the face is the center or not. And after that, we calculating here our offsets. It's mean that that's our offset of the 0 directions. So it is go to the move to the 20. It's mean that we are the right positions. So it is go to the minus 20. It's mean that we are the left positions, right? So you can see that direction is equal right. So you're already creating here a variable for that, for storing this, okay? And color, we give it here some colors, different colors. So if the previous directions is not equal to these directions, we just give it to here a command to the Arduino. It's mean that the right. So here you can go on here. So you can see that the serial command is coming here the right. It's mean that it will calling here the right methods. Okay. So same thing for the offset. So offset is in the minus 20. It's mean that we go to the left portions. So you can see that we basically encode it, and else we are in a center portions. Simple. And then we give it here some style the herd box. You can see rectangles and put text, and then we give it here some optionals. It's basically optionals. You can do it or not. It's basically giving some arrows. So in the center, it should just show here a ball, and how you go to the left portion, it will show the arrow like that. Okay, that you already see you in the demo, right? And then if the direction is a left, then you give it here an arrow line. We're creating here an arrow line in the left portion, and how the direction is the right portions, we just creating here an arrow line like that. And how the direction is the centers, it's mean that we just have circles, okay, that you already see in the demo, right? So then we show the image.imshow and that cb.this ones, okay? So this is how you can see that it basically work, okay? Now let's see, and let's push Peter to come and testing this out, okay? And after that, we will end up our video. Left, center, right, center, left, center, right, center. So that's it from my side. I hope you enjoyed this full tutorial, and make sure to subscribe to channels and share with your friends so that you will not miss our next projects. Okay, thank you and bye bye.